Hi everyone, and today we're looking at empirical formula. So we've looked at the mole concept so far, talking about what is a mole, and now we need to look at how all of this ties together with empirical formula. So when we talk about empirical formula, it's the formula that tells us the ratio of atoms that are present in the compound. It's different to our molecular formula that will tell us the actual number of atoms. So for example, H2O, there is 2 hydrogen atoms and 1 oxygen atom. As opposed to something like H2O2, which is hydrogen peroxide, which is telling us there's 2 hydrogens and 2 oxygens. But if I was actually to write that as the empirical formula, I would have HO. It's a 1-to-1 ratio. So it's the simplest whole number ratio that we can have. Obviously, sometimes we have non-molecular compounds, for example, like sodium chloride. Sodium chloride doesn't exist just with 1 chlorine atom and 1 sodium atom. They, as you know from your task, they are arranged in a 3D lattice where there is the electrostatic attraction between many chlorines and other sodiums. So that, in its case, is its empirical formula there. So non-molecular compounds will have empirical formula only. So copper sulfate, CuSO4, sometimes it'll be Cu2SO4, depending on the valency of copper. And for non-molecular compounds, the formula mass is actually the same as the empirical formula mass. So remembering that formula mass, atomic weight, molar mass, they're all the same thing. It's the sum of the masses of all the atoms that are in that formula there. So our molecular formula only really applies to molecular substances. So that is O2, Cl2, it can be H2O, any of those things that form discrete molecules there. So what we're going to do is have a little bit of a go at an example. We've done a prac already on that, so let's have a look here. How do we go about determining the empirical formula? So it's determined from the mass of each element that is actually in that compound. So if we know the masses of the elements in the compound, we can then work out the mole ratio. So we have a number of steps. First of all, we've got to obtain the mass of each element in the compound. So for our prac that we did, magnesium and oxygen, magnesium oxide, find out the mass of each element in that compound. Calculate the number of moles of each element using the formula moles is equal to mass over molecular mass. And then we convert the mole of each element to whole number ratios by dividing through by the smallest amount, the smallest mole number, dividing through, and then we get a ratio there. So it's much easier to do this with an example, so let's have a go. So carbon of oxygen and carbon, it contains 27.3% carbon and 72.7% oxygen by mass. Calculate the empirical formula of the compound. Now, if masses are given as percentages, we tend to presume the whole mass, say, is 100 grams that we have of that substance. So in this case, our mass of carbon will be 27.3 grams. Our mass of oxygen is 72.7 grams. So now I want to go, well, how many moles of carbon have I got? So I've got 27.3 grams present, and the molar mass for carbon is 12.01. So 27.3 divided by 12.01 gives us 2.28 moles. When I do this for oxygen, so 72.7 divided by 16, we will get 4.54 moles. So you can see there, 2.28, 4.54. So divide by the smallest number, which is 2.28. So 2.28 divided by 2.28 gives 1, and 4.54 divided by 2.28 gives 2. So that means I have 1 carbon to every 2 oxygens. So the formula, or the empirical formula, will be CO2. So I want you to have a go at this one, and we'll come back with some more examples once you're done. Okay, so looking here, we've got some material that we can pull out of this question. We have 0.05 grams of magnesium, so the mass of magnesium is 0.5. At the end, it's reacting with chlorine, and I get a mass of that. Now remember, mass is neither lost nor gained, the mass of chlorine will simply be that, take away the 0.5, and we've got a mass of 1.46. So here are our masses. Let's work out our moles. So I have got 0.5 grams of magnesium over the molar mass of magnesium, and I get 0.0206. For chlorine, I have got 1.46 over the molar mass of chlorine being 35.45 and 0.0411 moles. So if I divide by the smallest, I'll get 1 magnesium and 2 chlorines. So the formula then, as we know anyway, is MgCl2, and that is its empirical formula. We'll practice a few more. We'll talk soon.